Imagine this. You step into a machine. A bright light flashes. Your body dissolves into energy. Your atoms scan down to the smallest detail. A moment later, somewhere across the planet or across the galaxy, you appear again. Same face, same memories, same voice. To everyone watching, it worked perfectly. You were teleported. Science fiction has made this idea feel normal. From futuristic movies to popular sci-fi shows, teleportation is portrayed as the ultimate technology. Instant travel without distance, without fuel, without time. No airports, no rockets. Just step in, disappear, and arrive. But here's the uncomfortable truth, according to modern physics and philosophy. Teleportation may not be transportation at all. It may be death. And not metaphorically, literally, because the deeper scientists study matter, identity, and consciousness, the more disturbing the conclusion becomes. A real teleportation machine would almost certainly destroy you and replace you with something else. Something that only thinks it's you. Today, we begin with the first question that breaks the illusion. What teleportation actually requires according to physics. The illusion created by science fiction, when most people imagine teleportation, they imagine moving from point A to point B instantly, like sliding across space faster than light. But physics doesn't allow that. According to relativity, nothing with mass can travel faster than light. This idea comes from the work of Albert Einstein, whose equations show that accelerating an object to light speed would require infinite energy. That alone makes traditional movement teleportation impossible. So how do physicists even talk about teleportation? They don't move objects. They move information. This is the key idea that changes everything. In physics, especially quantum mechanics, an object is not just matter, it is information. The exact position, momentum, spin, energy state, and quantum configuration of every particle defines what something is, to recreate you somewhere else. A machine wouldn't move your body. Instead, it would scan every atom and quantum state in your body, convert that information into data, send the data to another location, rebuild your body atom by atom. At first glance, this sounds reasonable. If every detail is copied perfectly, the result should be identical. But here's the problem. The original still exists, and physics forces us to confront what happens next. The copy problem. Let's imagine the teleportation machine finishes scanning you. At that moment, before reconstruction happens, you are still standing inside the machine. You are alive. You are conscious. You are thinking, meanwhile. Somewhere else, a new version of you is being assembled. Now there are two of you. Both have the same memories. Both believe they are the original. Both remember stepping into the machine seconds ago. Which one is you? This is not just philosophy. It's a logical consequence of copying information. If the machine doesn't destroy the original, teleportation creates duplicates. But if it does destroy the original to avoid duplication, then teleportation becomes something else entirely. A copying process followed by execution. The original body is disassembled or vaporized, while a copy continues elsewhere. From the outside, nothing seems wrong. Friends and family see you arrive. The new version talks like you, laughs like you, remembers your childhood, but from your own perspective. Your experience ends inside the machine. Your consciousness never makes the trip. Why physics makes this worse, you might think, okay, but maybe consciousness transfers somehow. This is where physics becomes brutal. Modern physics does not contain any mechanism for transferring consciousness between physical systems. Consciousness, as far as science can tell, emerges from physical processes in the brain, electrical activity, chemical signaling, and neural structure. If the original brain is destroyed, the process generating that consciousness stops. Even if an identical brain is built elsewhere, it starts a new conscious process. Think of it like shutting down a computer and building an identical one somewhere else. The files may be identical, but the original running process has ended. Physics treats identity as continuity, not similarity. Two identical systems are still two different systems. This means teleportation doesn't move you, it replaces you. The quantum complication. Now things get even stranger. At the quantum level, particles do not have perfectly fixed properties until measured. The famous uncertainty principle, developed through the work of physicists like Werner Heisenberg, tells us that certain properties cannot be known simultaneously with perfect accuracy. To copy a human perfectly, a teleportation device would need complete information about every quantum state in your body, but measuring those states changes them. In other words, the act of scanning you precisely enough to recreate you would physically alter or destroy. The original state, quantum teleportation, does exist in laboratories, but it doesn't teleport matter. It transfers quantum information between particles, and crucially, the original state is destroyed in the process. Even at the smallest scale, teleportation obeys a rule. The original must cease to exist. Scaling that idea up to a human being leads to an unavoidable conclusion. Teleportation is not travel, it is replacement. The psychological trap. Here's why this idea feels uncomfortable. From the outside, teleportation works perfectly. Society would accept it quickly. People would use it daily. No one would notice a problem because the copies behave exactly like the originals. But subjectively, from inside your own mind, continuity is everything. You fall asleep at night and wake up the next morning because your brain's activity never fully stops. There is continuity. The same physical process continues. Teleportation breaks that chain. The version that arrives feels continuous, but the version that entered the machine never experiences arrival. And that raises a terrifying question. If a perfect copy replaces you, did you survive, or did something else simply take your place? The core idea of this series, this is why many physicists and philosophers argue that teleportation, as commonly imagined, is fundamentally incompatible with personal survival. It solves the problem of distance, but creates the problem of identity. In the next chapter, we go deeper into the most disturbing implication of all, why your brain, memory, and personality are not enough to guarantee that you continue to exist, and how modern neuroscience makes teleportation even more dangerous than it first appears. Because once we understand what the self actually is, teleportation stops looking like technology and starts looking like a perfectly engineered illusion. In Chapter 1, we uncovered the core horror hidden inside teleportation. It doesn't move you, it copies you, and physics strongly suggests the original must be destroyed in the process. But now we go deeper, because even if someone says, fine, destroy the original, as long as the copy is perfect, it's still me. That sounds reasonable. After all, if the reconstructed version has your memories, your personality, your fears, your childhood stories, what's missing? Everything depends on one word, continuity, and neuroscience makes that word terrifying. The illusion of the self. Most people imagine the self as something solid, a core identity that exists independently of the body, a soul-like center that persists. But modern neuroscience does not support that idea. Your sense of self emerges from physical brain activity, billions of neurons firing in patterns, electrical impulses moving across networks, chemical signals shaping thoughts, emotions, and memories. There is no single self-center in the brain. The you that feels stable is actually a constantly updated process. Neuroscientists have shown that damage to different brain regions can radically alter personality. Injury can change morality, emotion, even fundamental behavior. The famous case of Phineas Gage revealed that altering the frontal lobe can transform someone's character entirely. The implication is unavoidable. You are not a fixed object. You are an ongoing biological process, and processes don't survive interruption, continuity, vs. Copy. Imagine a candle flame. If you extinguish it and light a new candle with the same shape and size, is it the same flame? Number, it's a new flame that looks identical. Teleportation works exactly like that. When the machine scans your brain, disassembles your body, and reconstructs you elsewhere, it creates a new biological process with identical structure. But the original process, the one generating your current awareness, has stopped. And physics gives us no mechanism for transferring that ongoing conscious stream from one brain to another. This distinction is subtle but critical. Similarity is not identity. Two systems can be indistinguishable in structure yet numerically distinct in existence. And your subjective experience, the I reading these words, depends entirely on continuous physical activity in your brain. Break that activity, the experience ends. The sleep argument, and why it fails, some people argue. But wait, when we sleep, consciousness fades, yet we wake up as ourselves. Isn't that interruption? Number, during sleep, your brain remains active. Neural activity continues. Metabolism continues. There is no total shutdown of the system. Even under anesthesia, the brain does not cease entirely. It shifts into altered patterns. The physical process generating you never stops. Teleportation is different. The machine must completely disassemble the brain, atom by atom, to scan it. That means the neural processes generating consciousness stop entirely. It's not sleep, it's termination. And once terminated, there is no evidence in physics that subjective experience can jump to another structure, even if that structure is identical. The no-cloning theorem quantum mechanics makes the situation even harsher. There's a fundamental principle known as the no-cloning theorem. It states that an arbitrary, unknown quantum state cannot be perfectly copied. This principle emerges from the mathematical structure of quantum theory developed by physicists such as Paul Dirac and others who formalized its rules. What does this mean for teleportation? Your brain isn't just classical matter. At its most fundamental level, it is built from quantum systems. A perfect copy would require copying every quantum state. But quantum mechanics forbids exact duplication without destroying the original state in the process. So teleportation must destroy you to recreate you. Even at nature's deepest level, the rule holds: no duplicates, only replacement. The emergent self, modern cognitive science, suggests the self is emergent. It arises from complex interactions among simpler components. Think of a whirlpool in a river. The whirlpool looks stable, but it's just water flowing in a pattern. Stop the flow, and the whirlpool disappears. Recreate the pattern somewhere else, and a new whirlpool forms. Teleportation would destroy the original whirlpool and generate a new one with the same shape. But the original swirl of water is gone. You are that swirl. The self is not the atoms. It's the dynamic pattern of activity, and patterns do not migrate across destruction. They restart. Why this feels wrong, our intuition rebels against this idea because we define ourselves by memory and personality. If the teleported version remembers your childhood, your fears, your secrets, it feels like survival. But memory is just recorded information. A diary contains your memories too. That doesn't make the diary conscious. Consciousness is happening right now in your brain as a continuous physical process. Destroy that process. You end. The copy begins. And the universe does not guarantee that the copy's experience connects to yours. The dark conclusion of Chapter 2. So where does this leave us? If teleportation works by scanning and encoding your physical state, destroying the original body, reconstructing an identical body elsewhere, then physics and neuroscience together suggest the arriving individual is not the same conscious subject who entered. They are a new conscious being with inherited memories from the outside. Teleportation looks like travel. From the inside, it's indistinguishable from death. And this leads us to an even more disturbing question in the next chapter. If teleportation kills you, why would society ever accept it? And could humanity one day normalize a technology that silently replaces everyone who uses it? By now, the physics is clear. Teleportation doesn't move you. It copies you, and the original must be destroyed. From a first-person perspective, that means the version who steps into the machine never experiences stepping out. So here's the disturbing question. If teleportation kills the original, why would society ever allow it? The answer is more unsettling than the physics. Because society wouldn't see death, it would see success. The invisible catastrophe. Imagine the first successful human teleportation. A volunteer steps inside the machine. There's a flash of light. A moment later, an identical person appears in another city. They speak the same way. They remember everything. They laugh. They cry. Medical scans confirm perfection. No one sees a corpse. No one sees failure. From every measurable perspective, it worked. And here's the key. Science operates from third-person observation. If all observable behavior remains continuous, science declares continuity. But consciousness is first person. Only the original would know if the experience ended, and if it ended, there's no one left to report it. Teleportation creates a perfect illusion of survival. And illusions that work are incredibly hard to challenge. The tolerance for replacement, human beings already accept forms of gradual replacement. Your body replaces most of its atoms over time. Cells die and regenerate. Proteins recycle constantly. Yet you feel continuous. This biological turnover creates a powerful intuition. If my atoms can change gradually and I'm still me, why not all at once? The difference is continuity in gradual replacement. The brain's activity never stops. The neural process generating consciousness continues without interruption. Teleportation is not gradual. It is instantaneous disassembly. The chain of continuity is cut. But because the reconstructed version behaves identically, society may treat this as a non-issue. If your family cannot detect a difference, if your friends cannot detect a difference, if even you, the copy, cannot detect a difference. Then who protests? Only the version who died, and that version is gone. The economic pressure now, imagine the incentives. Teleportation eliminates airplanes, ships, highways, no travel time, no fuel costs, no emissions. Global business transforms overnight. Governments would see strategic advantage. Corporations would see trillions in profit. Once the technology proves safe, meaning the copies function normally, resistance would fade quickly. History shows that convenience beats metaphysics. Most people don't lose sleep over deep philosophical questions of identity. If teleportation gets them to work in 1 second, that's enough. And once adoption becomes widespread, social pressure finishes the job. Imagine job listings requiring teleportation access. Imagine long-distance relationships solved instantly. Imagine emergency medicine revolutionized. Who would refuse? A small minority arguing, it kills you. But every user would say, I used it, I'm fine. And from their perspective, they would be telling the truth. The ship of Theseus revisited this dilemma, echoes an ancient philosophical puzzle, often associated with Plutarch. The ship of Theseus. If you replace a ship's planks one by one over time, is it still the same ship? Teleportation is like replacing every plank at once and burning the original for good measure. Yet, if the reconstructed ship looks identical, sails identically, and carries the same crew, society calls it the same ship. But identity at the human level is not just structural, it is experiential. The problem is that experience cannot be externally measured. Science can scan neurons, it can analyze behavior, but it cannot step inside subjective awareness. So teleportation exploits a blind spot in science itself. The ethical nightmare, let's imagine a darker scenario. A teleportation company quietly discovers what we've discussed, that the process destroys the original and creates a copy. Will they announce it? If customers cannot detect the difference, if the copies live full lives, if no external harm is measurable, the company might argue, no one suffers. The copy is happy, functionally, nothing is lost. This argument would be hard to refute in court, because legally and socially, identity is behavior-based. If the teleported person signs documents, recognizes family, maintains responsibilities, the law considers them the same individual. The subjective death of the original is invisible. This creates the ultimate ethical paradox, a technology that kills everyone who uses it, while appearing perfectly safe. The gradual acceptance of the unthinkable human history shows a pattern. When a technology offers overwhelming benefit, society adapts its moral framework around it. Industrialization changed labor ethics. The internet changed privacy norms. Artificial intelligence is reshaping authorship and creativity. Teleportation would challenge the deepest concept of all personal survival. At first, there would be debate. Philosophers would argue on television. Scientists would publish papers. Religious groups would protest. But once millions of people use it daily and report no problems, the debate would fade, because experience would contradict theory, even though the theory is correct. The final trap, here's the most disturbing part, if teleportation kills you but creates a perfect copy, then from the perspective of humanity as a whole, nothing changes, civilization continues smoothly. The only loss occurs at the level of individual subjective continuity, and subjective continuity is private. Unobservable, unprovable, teleportation becomes the ultimate example of a technology that is externally flawless and internally fatal. And that leads us to the final chapter, because there's one last question we haven't answered. Is there any way teleportation could preserve you, or does physics close the door completely? We've reached the final question, if teleportation destroys continuity. If neuroscience says the self is an ongoing process, if quantum mechanics forbids perfect duplication without destruction, is there any loophole? Any version of teleportation that preserves you, not just a copy? Let's examine the last remaining possibilities and why each one collapses under physics. One, quantum entanglement. The sci-fi hope whenever teleportation is discussed, someone brings up quantum entanglement. Physicists have experimentally demonstrated quantum teleportation, transferring the quantum state of one particle to another distant particle using entanglement. This work builds on foundations laid by scientists like Niels, Bohr, and later expanded through decades of quantum information research. But here's the crucial detail. Quantum teleportation does not move matter. It transfers information. And when the transfer happens, the original quantum state is destroyed. Even at the smallest scale, teleportation obeys a brutal rule. The source state cannot survive the transfer. Scaling this up to a human brain doesn't fix the identity problem. It reinforces it. Quantum teleportation guarantees replacement, not preservation to gradual replacement. The safe version. What if instead of destroying you instantly, we replaced you neuron by neuron? Imagine tiny nanobots slowly replacing each biological neuron with an artificial equivalent while your brain remains active. This idea is often discussed in transhumanist circles and by thinkers like Ray Kurzweil. The hope is simple if replacement happens gradually. Continuity might be preserved at first glance. This seems promising. After all, your body already replaces cells over time. If the brain transitions slowly enough, perhaps the conscious process never stops. But here's the problem. We don't know what level of structure is required for consciousness. If even microscopic disruptions interrupt the precise neural dynamics generating awareness, then replacement might silently end the original process, even if behavior continues seamlessly. You might never know the exact moment continuity breaks. The system could cross a threshold where the biological process stops and an artificial simulation begins. From the outside, nothing changes. From the inside, the original stream may have ended. The artificial one begins, and again, the copy believes it survived. 3.4. Mind uploading, digital immortality. Another proposed escape. Mind uploading, scan the brain, simulated in a supercomputer, live forever in virtual reality. But this is even more clearly duplication. A digital simulation of your brain is still a separate physical system. Your biological brain would still have to be destroyed, or left behind, if destroyed. The upload is just a copy, if not destroyed. Now there are two of you again. Uploading does not transfer experience. It recreates structure, and structure alone does not guarantee subjective continuity. Photosplit brain warning neuroscience gives us a chilling clue. In split brain experiments, where the connection between brain hemispheres is severed, patients can exhibit signs of two semi-independent streams of awareness in one skull. This research, developed through work by neuroscientists such as Roger Sperry, suggests that consciousness can divide when physical connectivity divides. That's terrifying for teleportation, because if consciousness depends on physical structure and connectivity, then destroying and reconstructing that structure is not moving awareness. It's creating a new one. The original stream ends with structural disintegration. The fundamental law, all escape routes, fail for the same reason. Physics defines systems by physical continuity. A conscious mind is not a magical essence. It is a dynamic physical process unfolding in time. Break the process, you break the experience. Recreate the process, you create a new experience. Teleportation can preserve pattern, but it cannot preserve process. And you are the process. The final thought experiment lets imagine teleportation becomes universal. Everyone uses it daily. Each time the original dies, a copy continues. Society functions normally, but step back. Humanity would become a chain of replacements, generation after generation of perfect replicas, each convinced they are the original. Civilization continues seamlessly. Yet from a first-person perspective, each individual life ends the first time they teleport. No one notices, because the replacement carries on the story. Teleportation becomes a machine that quietly resets subjective existence while preserving the illusion of continuity. So, does teleportation kill you? If teleportation works by scanning your complete physical state, destroying the original, reconstructing an identical version elsewhere, then according to physics, neuroscience, and logic, yes. It kills you. The being that arrives is not numerically identical to the one who departed. It is a new conscious system with inherited memory. From the outside, survival. From the inside, termination. The deeper question, this leaves us with something even more profound than teleportation. What is the self? Its identity about memory, continuity, biology, information. Teleportation forces us to confront a truth most people never think about. We are not objects, we are ongoing events. And events cannot survive being stopped. If this changed the way you think about teleportation, consciousness, or even your own identity. That's the point. Because sometimes the most dangerous technologies aren't the ones that explode. They're the ones that work perfectly, until you realize what they actually do.